So let's have a look at an example of how we factorise, and then we'll look at some on the board. Factorising is the opposite operation to multiplying out brackets. To factorise, we find the highest common factor of each term and then take it outside the brackets. So for example, 8c plus 12, well, the highest common factor here is 4. So we would take 4 outside the bracket and write what is left inside the bracket. So we would have 4 on the outside and then 2c plus 3 on the inside. Remember, those numbers on the inside of the bracket inform us how many times the 4 goes into that original expression. Now remember, we've taken out a factor, so what's left in the bracket represents how many times that common factor goes into each term. Now factorising always tends to prove slightly more problematic than multiplying out brackets, so we're going to go through these examples together on the board. First off, let's look at 4x plus 12. Now, in terms of the highest common factor, the highest common numerical factor, of 4 and 12, well, the highest common factor would be 4. Now let's think what that leaves us with in our bracket. Well, I had 4 lots of x here, and obviously there's only one lot of 4 in 4, so it would leave me with 1x, but remember we only ever write x when it's just one of them. How many 4s are there in 12? There's 3 4s in 12, so that becomes plus 3. So my final factorised expression is 4 lots of x plus 3. Now when you factorise something and you want to check if you've done it right, multiply out the brackets again and it should always get you back to what you had originally. Let's look at another one now. 5ab minus 10a. Now in this case, there's not just a number we can take out, but also a letter. And I'm hoping you can see that letter's the A. Let's take our number out first. The highest common factor of 5 and 10 is 5. And they also have an A in common. So I'm going to take out the A as well. Now, when I put what's left in my brackets, well, how many 5s are there in 5? There's 1. The A I already have, so I don't need to leave any more A's in the bracket. The only thing I'll be left with is that B. And then here is going to be a negative. The A already has come out. And how many 5s are there in 10? There's 2. So my final factorised expression is 5a multiplied by b minus 2. Carrying on, let's make them a little bit trickier now. X squared plus xy minus xw. Now you can see here, there's no numerical term that I can take out, but there is an x that I can take out, as each term within the expression contains an x. So if I take that x out, what am I going to be left with? Well, if I take x out, x squared is the same as x multiplied by x. So if I've taken one of those x's out, it means I'm left with an x inside. X times y. Well, if I've taken the x out, that's going to leave me with just y. And xw, if I've taken the x out, I'll just be left with w. But remember, it's minus w because of what there is in the question. And there's my final factorised expression. You know if you factorised it properly because what's in this bracket will not factorise anymore. And again, you can always check that when you multiply out the bracket, it gets you back to the original answer. One more example. 12p squared q cubed plus 9p cubed q minus 3pq. So lots of p's, q's, numbers, powers in this one, but again, work through systematically and you'll be able to factorise it nice and easily. Let's look first of all for a number. Our coefficients are 12, 9 and 3. So what's the highest common factor of 3, 9 and 12? It's 3. Now when it comes to taking out a letter as a factor, you can only take out the lowest power that there is in your question. You can't take out p squared, for example, if there is just a p term in one of the other terms in your expression. You can only take out the lowest power. So in this case, I can only take out p. Let's look at my q's now. Q cubed here, q on its own there, and q on its own there. So I can only take out the lowest power, so it would just be a q to the power of 1 again. So that's all I can take out. Now let's write our bracket and show what we're left with inside. How many 3's are there in 12? 4. If I have p squared and I've taken one of those p's out, well, you remember p squared is just p times p. So if one of the p's has gone, I'm left with a p in the bracket. Now q cubed, if I've removed one of those q's, that's going to leave me with q squared. Because remember, q cubed would be q multiplied by q multiplied by q, and I've taken one of those out as a factor, so it would just leave me with q squared. The next term was 9p cubed q. So if I've taken 3pq out, how many 3's are there in 9? Well, there's 3. P cubed here, and I've removed one of the p's, so it leaves me with p squared. The q I've taken out, well, I only had a q there to start with, so there's no q in that term in the bracket. And the final bit, 3pq. Well, I've actually taken out 3pq, so I've taken out everything that was in that term. That doesn't mean the term disappears. It does, in fact, mean I just write 1 in the bracket. So that will be subtract 1. Remember, you can't make the term disappear because you've taken out all parts of it out of the bracket. Otherwise, it wouldn't exist anymore. We have to show that it's still there by writing the number 1.